Hello everyone. This will be the first of our series on SAT practice. The approach that we're going to take here is to work through practice tests, and each video will consist of me working through 5 questions and kind of giving some exposition on how I am approaching certain problems and um, I guess the process that I'm following. We're going to start today's video by looking at the 2018 official SAT study guide, and we'll focus specifically on the math sections. So in this particular exam, so this is the first exam, exam 1, the first math section is section 3. So we're going to get started here. So the problem will be on the right side of the screen. So we'll look at the first problem here. Right. So x minus 1 over 3 is equal to k. We're told that k is equal to 3. We're asked to solve the value of x. So this is a nice warm-up problem. There's not really much more to do other than substitute in the value for k. So we'll go ahead and do that. So we'll say x minus 1 over 3 equals 3. Now we just have to isolate for x. So we get x minus 1 equals 9, which implies that x equals 10. So the answer here is D. Okay, let's move on. Let's get problem 2. So problem 2, we're told that I is defined to be the square root of negative 1. And we're asked to find the sum of 7 plus 3i plus negative 8 plus 9i. So it's perfectly natural to kind of not have seen complex numbers before. So I in this case is defined to be the square root of negative 1. So this is the kind of base component of any complex number. So a complex number, in case you haven't seen this before, is given by this form. So you have a real part and an imaginary part. Don't be too confused by this. It's perfectly normal to not have seen this. Not every high school math class goes into complex numbers. But the way that you can think about manipulating these numbers is, similar to how you would manipulate an algebraic expression where you have, let's say you have something like 7 plus 3x plus negative 8 plus 9x, right? So here, the approach you would take would be to combine like terms, right? And it's very similar for what we would do in this case. So we would combine the coefficients of 1, which in this case are 7 and negative 8, and then I, which in this case are 3 and 9. So we'll get 7 plus negative 1 is negative, 7 plus negative 8 is negative 1, and then 3i plus 9i is 12i. So that's really all there is to it. You just have to combine like terms, and you'll get the right answer. So that's the second problem solved. Let's move up here for a second. Oh, excuse me. So third problem, we're told that on Saturday afternoon, Armand sent M messages each hour for 5 hours. So let's write this out, right? So we're told Armand M messages each hour, and he did this for 5 hours. And then Tyrone sent P messages each hour for 4 hours. And now we're asked to find the expression that represents the total number of messages sent by Armand and Tyrone on that afternoon. So you'll notice that as I wrote out this problem, I included the units here, right? So we have messages per hour. And the reason we do that is because this is a really good introduction to a very useful practice, not only for the SAT, but for analysis in general. And that is to carry through units. And the reason we do that is when we multiply quantities, we not only multiply, let's say the numerical value here, we also multiply the units, right? And so this is actually something you've seen before. Maybe you haven't really thought about it this way, but think about it like a rectangle, for example, right? So a rectangle has dimensions, of length and width, and let's say the units of these dimensions are meters, right? So when we're asked to find the area of this rectangle, right, we know that the area is going to be the product of the length and the width. But the units of the area are going to be meters squared, right? So how do we arrive at this number, at this result? So meters squared is actually meters times meters, right? So what we did was we took the length in meters and we multiplied it by the width in meters, and we kept the fact that there was just meters associated with each of these dimensions, and that manifests in the product, right? And so we're going to do something similar here with the when we want to basically go from messages per hour to total number of messages, right? So let's look at Armand again. And so if you want to find the total number of messages sent by Armand, what we need is units of messages at the end of all of this, right? So you can think, well, how can I multiply, or how can I combine these quantities in a way that I get messages at the end of this, right? So immediately you can see that, if you do m messages per hour multiplied by 5 hours, the hours here in the denominator and the numerator will cancel each other out, and you'll be left with 5m messages. So this is the total number of messages sent by Armand. And you can repeat this process for Tyrone. Right? In Tyrone's case, you will have p messages per hour multiplied by 4 hours, and you get 4p messages at the end of this. And you notice, right, that the units that we wanted, which were messages, is actually what we get back over here. We get 4p messages and 5m messages. And now the total number of messages, right, sent by both of them will simply be the sum, right? We'll look at the messages sent by Armand, and we'll look at the messages sent by Tyrone. So that's going to be 5m plus 4p. So the answer here is C. Okay. So let's look at problem 4. So here we're told that Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of repairs she has left at the end of each day can be estimated with the equation P equals 108 minus 23D, where we're told that P is the number of phones left and D is the number of days worked, right? And so in this problem, we're asked to interpret the value of this 108, or the meaning, sorry, of this 108. So the way to sort of think about this problem is, again, unit analysis will play a big role here. So we're told that P has units of phones, right? So it has units of phones. And since D has units of number of days worked, 23 in this case, although it's a coefficient, it has these invisible units of phones per day, right? And this makes sense because when we look at phones per day and we multiply by D days, right? Days will cancel out and we'll be left with 23D phones. So when we're adding terms, just like everything we've done already, we have to ensure that the units of the quantities that we're adding are consistent. So that must mean that the units of 108 is also phones. Now, of course, you could have seen that right away when we looked at the units of p, right? But this is, just to since we're doing this as practice, it's good to sort of think a little bit more deeply about the problem when we have an opportunity. So we can also graph this, right? So we'll look at something like our axis here will be d, so the x-axis here will be d, and the y-axis will be p. And we'll start at 108, right? This is our intercept. And you have a negative slope, so it's going to go down. So when we talk about the intercept, right, the significance of this intercept is the value of this function at 0 input, right? And that must mean that this is the number of phones that she has left when she's worked 0 days, which is the same thing as the number of phones she has at the beginning of the work week. And so this is our insight. We want to find the answer choice that best represents that, right? So let's take a look at our answer choices now. So A, she'll complete the repairs within 108 days. No, that doesn't match our insight at all. B, Kathy starts each week with 108 phones to fix. So B looks like the right answer. We can just be very thorough and look at choices C and D. So Kathy repairs phones at a rate of 108 per hour. In fact, actually, her rate of repair is 23 per day. So that doesn't make sense. And you see the same thing show up in problem D, in answer choice D. So that's how we can look at problem 4. So let's consider the 5th problem now. So problem 5, we're told x squared y minus 3y squared plus 5xy squared minus negative x squared y plus 3xy squared minus 3y squared. And we're asked to basically simplify this expression. So I think if you're not comfortable doing this kind of math in your head, that's totally fine. I would just say go through this practice and actually distribute distribute this negative across your parentheses and then combine like terms, right? So this is the process you can follow. It's very systematic and it's consistent. You can use it anytime, right? So we'll just write out the terms in the first parentheses again. So we have x squared y minus 3y squared plus 5xy squared. And now we're going to distribute our parentheses. So we have a negative times a negative x squared y, so that becomes a positive x squared y. We have a negative and a positive, so that becomes a negative 3xy squared. We have a negative and a negative again, so again we get a positive 3y squared. And now we basically will combine all the terms, all the coefficients of the corresponding terms, right? So we'll have x squared y, so I'll underline that with 1 underline. Then we have y squared, so that's these two terms. And then we have xy squared, so that's these two terms. Right, so x squared y plus x squared y, so that's 2x squared y. Right? Negative 3y squared plus 3y squared, well that's 0y squared, so I'm not going to write that. Then 5x squared y minus 3x squared y is plus 5xy squared minus 3xy squared is plus 2xy squared. So the answer in this case is C. And I'll conclude that for this video. We'll pick it up again for the next one. See you in the next video.